Good day, ladies and gentlemen. My name is KAPIAMBA FABRICE. Today I'll be talking about metal analysis from e-cigarette aerosols. To conduct this work, we were motivated by a few facts on e-cigarettes. First of all, they were mainly designed as a quick smoking aid, and hence since their introduction, their use has been on the rise, as we can see from the figure on the left-hand side, where we can see that since the last decade, the use of e-cigarettes has been on the rise. Second, talking about the figures, we can see that about 11 million American vape, and of these, 50% of them are under age 35, whereas a fifth of them are children under 18. Thirdly, the popularity of e-cigarette aerosols is due mainly to the ease of operation of these devices, the social media, and more importantly, the attractive flavors that have been used. And all these leads to a certain uncertainty, which is proven by the lack of proper regulations. Few studies have been published that have characterized the e-cigarette aerosols, and of these, VOCs have been reported: nicotine, nitrophane, particles, flavoring, and more importantly, the metals, because here we are talking about metals in today's presentation. A comparison, further on, a comparison between the amount of these components in e-cigarette and tobacco cigarette have been also reported. On the table, it's more apparent that some chemicals are orders of magnitude higher in tobacco cigarette than in e-cigarette. For instance, formaldehyde is 10 times more in tobacco cigarette than it is in e-cigarette. Formaldehyde even furthermore, like more at about 450 times more. So, besides the lack of significant characterization, some health effects related to the specific component of these e-cigarettes emissions have also been reported. These hit mainly the cardiovascular and the pulmonary systems. For example, one short-term effect on the pulmonary system is the increased flow resistance, whereas on the long term, the effects include like airway inflammation. Currently, now, what is the main problem here? Currently, authorities have had time regulating the use of e-cigarette because of insufficient data that's to support their decision. And at the same time, the e-cigarette use is increasing exponentially. Therefore, we aim at in this work, we aim at looking at the metal content alone in e-cigarette aerosols to contribute to that effort. We looked at the effects of selected parameters from the e-cigarette devices that affect metal emissions and the type, which include the type, the brand, power, and nicotine concentration in the e-liquid. And also we went on to sample secondhand aerosols. We used a very simple experimental setup, schematically shown here. The e-cigarette aerosols, with the device itself was connected to a filter cassette, and where the aerosol were withdrawn using a program, a mass flow controller. The international puffing standard was followed. That is like a 2-second puff at 1 liter per minute, with a 1 minute interval between puff to make up a volume of 35 ml per puff. We collected 30 puffs per sample. After 30 puffs, the filter was removed, digesting the nitric acid and the metal measured. The metal concentration measured using the ICP-MS. We tested 5 metals: chromium, copper, manganese, nickel, and zinc. We observed a difference in some metals concentration across the 3 brands that we tested. We tested the Vapor for Life, that's the most popular locally, the Vupu, and the Joe, that is the most popular e-cigarette brand in the US. For example, on copper and manganese, we saw that the concentration or the mass emissions as normalized here in nanogram per 10 puff are orders of magnitude apart. The reason might be, it may be explained, the reason explaining this discrepancy include the different materials that may be used by each device to make the coil, the heating coil, because remember the metal that transfers from the heating coil to the aerosols or to the e-liquid, depending on which mechanism it follows. We went on to look at the effects of flavors and nicotine concentration on metal emissions. As shown in the figure on the left-hand side here, we can see that changing the fluid with menthol, Virginia tobacco, and classic tobacco didn't show significant change in the metal emission. On the right-hand side, rather, when we check the nicotine concentration, we observe that there's an increase metal emission with increased nicotine concentration. The reason might be the saturation ratio that is affected by the nicotine concentration, and thus enhancing vapor formation and releasing more particles. We went on. We also looked at the effect of power on the metal emissions. We noticed that at increasing the power showed high metal emission, very likely due to the increase in coil temperature at higher powers because of the high resistance that go along, and thus more metal were transferred to into the aerosols. We cannot stop the people from smoking. There are just the life choices that they make. How about bystanders, people who do not smoke but are exposed to these e-cigarette aerosols? For instance, in the US alone, a third of high schoolers have been reported to have been exposed to secondhand aerosols. Thus, we also looked at the content of metals in the secondhand aerosols. We employed a series of filters that mimic the deposition efficiency of the human lungs in the so-called simulated respiratory system. My lab mate will present this work tomorrow. The details are here enclosed in the box. Please go and see the details on this simulated respiratory system, where we collected primary aerosol prior to the series, the series of filters, and we also collected after, which we named the simulated secondhand aerosols. To understand boxes, the unshaded boxes represent the metal from primary aerosols, whereas the shaded areas represent the secondhand aerosols. Thus, we can see that the metal concentration remains higher in secondhand aerosols and poses a significant risk in air quality indoors and outdoors. Therefore, the European Medicine Agency set the maximum daily exposure limit that has been shown with dashed line, and in conclusion, would say that even secondhand aerosols are still higher than the daily limit. In conclusion, we learned that e-cigarette aerosol contain a high concentration of metal regardless of the brand. Also, setting parameters on devices and the nature of e-cigarette affects the metal emission. And lastly, secondhand aerosols contain 80 to 90% of the metals that are from primary aerosols, and there's a need to be regulated. We would like to thank the center, the CBR, and the NSF for funding this work. Thank you.